Now in this lecture, we are going to look at how Dijkstra's algorithm works in practice. So in the previous lecture, we have created Dijkstra's algorithm like this, and we have said that we are going to use path print function inside this Dijkstra's algorithm. So I've just copied this function from the previous lecture that we created in case of BFS algorithm. So this code is the same, so that's why I've just copied it from the previous lectures and passed it over here. Now before checking how Dijkstra's algorithm works in practice, we need to add one more method. So this method will add weighted edge to our graph. So in this case, it's going to be like this: public void. So the name of method will be add weighted edge. So it's obvious that it's going to take three parameters. So first parameter will be the first node's index. The second parameter j will be the second node's index, and the third parameter will be the cost of edge. In this case, it's going to be d. So here, the first thing that we are going to do, we are going to get first node from the node list that we created over here. So we are going to get it based on the index that we are getting from here. So it's going to be the type of weighted node. So I'm just going to copy it from here. So I'm going to put first. So it's going to be node list dot get. So we are getting it based on the index of I. So then I'm just going to create another node over here, which will be the second node, and in this we will have the second nodes. So in this case, we are getting from node list with the index of j. Then I'm going to add edge between them, and in this edge we will have d as a cost. So it's going to be like first dot weight map. So we are going to use put method. So it's going to be second with the d. So it shows that from first to second we have a directed edge. In this edge we have a weight of d over here. Now with this we have successfully implemented our method. Now let's see how this is working in practice. So as you remember in our previous lecture, when we are discussing the pseudocode of the Dijkstra's algorithm, we had a graph like this. So I'm just going to create this graph in main class over here. Then I'm going to call Dijkstra's algorithm for this graph over here. So for creating weighted graph, the first thing that we are going to do, we are going to create an array list in which we will have nodes. So it's going to be like this: array list with the type of weighted node. So here again, I'm just going to copy it from here, weighted node, and pass it over here. So the name of the array list will be node list. So in this case, it's going to be the type of weighted node. So it's going to be like this. Now then, I'm going to create these nodes that we have in our graph over here one by one, and I'm going to add this node to this node list over here. So we know that in case of this graph, we have 7 nodes, which are A, B, C, D, E, F, G. So I'm just going to create them one by one and add to this node list over here. Then based on this node list, we are going to create our graph. So it's going to be like this: new weighted node. So a new node will be created based on the weighted node class. So it's obvious that the name of node for first one is A and the index will be 0. So with this, we have successfully created node of A and inserted to this node list over here. So I'm just going to copy paste this code here several times for other nodes. So the second node will be B with the index of 1. So the third node will be C with the index of 2. And fourth node will be D with the index of 3. And fifth node will be E with the index of 4. And sixth node will be F with the index of 5. And seventh node will be G with the index of 7. Then what we are going to do, we are going to create graph based on this node class over here. So the graph will be created based on the weighted graph class over here. So I'm just going to copy it from here and pass it over here. So it's going to be weighted graph. So I'm going to name it new graph. So it's going to be new weighted graph. So as a parameter, it's going to take node list. Then after creating this graph over here, we see that we have edges between these nodes over here. So we are going to add edges one by one. So the first edge is from A to B, and in this edge we have a cost of 2. So that's why I'm just going to call new graph dot. So we are going to use the method that we created here, add weighted edge. So in this case, first index will be the index of the A, because we are creating from A to B, so which is 0, and the index of B is 1, and the cost from A to B is 2. Then we are going to continue for all other nodes over here. So I'm just going to copy it from here and paste it over here several times for other edges. And then we are going to continue out our edge over here. Now the next edge is from A to C. So the index of A is 0 and the index of C is 2 and the cost between them is 5. And then we are going to continue to the next edge. The next edge is from B to C. So the index of B is 1 and the index of C is 2 and the cost between them is 6. Now we are going to continue to the next edge. The next edge is from B to D. Now the index of B is 1 and the index of D is 3 and the cost between them is 1. Now the next edge is like this from B to E. So the index of B is 1 and the index of E is 4 and the cost between them is 3. So we are taking all edges from this graph over here. Now we are continuing to the next edge. The next edge is from C to F. So in this case, the index of C is 2 and the index of F is 5 and the cost between them is 8. Then we are going to continue to the next edge. The next edge is from D to E. So the index of D is 3 and the index of E is 4 and the cost between them is 4. And the next edge is from E to G. So the index of E is 4 and the index of G is 6 and the cost between them is 9. And the last edge is from F to G. So in this case the index of F is 5 and the index of G is 6 and the cost between them is 7. So with this we have successfully created this edge from this picture over here into this graph over here. Now then I'm just going to call Dijkstra algorithm for the source node, which is A. So in this case I'm just going to first print out this message to the console. So it's going to be system out println. So the message will be printing Dijkstra from source A. Then we are going to call Dijkstra for the node A. So to get node A, we are going to put node list.get. So the index of A is 0. It's going to be like this. Now, after doing so, if we run our code, you see that we didn't get the correct result, because if we go to our weighted graph class, we see that when we are creating add weighted edge method, we have missed one line over here. So this line should be like this. First, we are selecting first.neighbors and adding the second node to these neighbors over here, because we are creating a link between first and second. So in this case, we are adding directed link from first to second. So we have missed this line of code over here. Now, after adding this line of code into add weighted edge, if we run our code, you will see that in this case, it's printing out the result that we got in our previous lecture. So this is our result. So as you can see, from A to B, the distance is 2. From A to C, the distance is 5. And from A to D, the distance is 3. We have to go to A, B, and D. And from A to E, the distance is 5. And we have to go A, B, E. And from A to F, the distance is 13. So we have to go to A, C, F. And from A to G, the distance is 14. So we have to go A, B, E, G. So as you can see, the result that we got from this Dijkstra's algorithm is identical with the one that we got when we are doing dry run. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented Dijkstra's algorithm and we have seen how this is working in practice. So see you in the next lecture.